Concentrations of solutions. Molarity is a way to tell concentration, which is a measure of the amount of solute dissolved in solvent. Dilute and concentrated solutions, those are relative terms, which means a small amount or a large amount, but molarity will actually give me a numerical amount for concentration. Molarity, capital M, is moles of solute divided by liters of solution. So let's look at some examples with molarity. The first one, I want to know the molarity of the solution. In this case, it's going to be moles of glucose, which is C6, H12O6, divided by liters of solution. Because glucose is my solute, so I have 36 grams of glucose. But I need moles, so I need to divide by the molar mass of glucose in 1 mole. The molar mass of glucose is 180 grams, divided by liters of solution, which is 2 liters. And so the numerical value for concentration, 0.1 molar, and we can just label that as a capital M. Second example, a solution has a volume of 250 mils and contains 0.7 moles of sodium chloride. What is the molarity? Molarity is moles of solutes. Well, in this case, my solute is NaCl, so 0.7 moles of NaCl divided by the volume of solution in liters. 250 milliliters is 0.25 liters. So my concentration for this, 2.8 molar. And again, just a capital M will suffice for the unit. Number 3, how many moles of ammonium nitrate are in 335 mils of a 0.425 solution? Well, we have molarity equals moles over liter. So if I want to solve for moles of solute, I would take my concentration times my volume in liters, so 0.425, multiplied by the volume in liters, which is 0.335 liters. So the amount of moles of solutes, .142 moles of ammonium nitrate. Last example under molarity. How many grams of calcium chloride are in 250 mils of 2 molar calcium chloride? Well, I want to solve for moles of solute first because that's the calcium chloride. So we're going to take the concentration, which is 2 molar, times the volume, 0.25 liters. That's going to give me 0.5 moles of CaCl2, and I want it in grams. So if I want it in grams, all I have to do is find the molar mass of CaCl2, and 1 mole, the number of grams from the periodic table is 111.1, and that will get me 2 grams of calcium chloride. So that's my molarity equation. Molarity is the most common concentration unit that we will use. When you dilute something, you add more solvent. In most cases, it's adding more water to this solution. The number of moles before or after doesn't change. So my dilution equation is M1 times V1 equals M2 times V2. So here are some dilution equations. I'm starting off with a fairly concentrated solution of Ki, 4 molar. I'm ending up with 0.76 molar. How many mils do I need? So we have M1 V1 equals M2 V2. My initial molarity is 4. My initial volume is what I'm looking for. My final concentration is 0.76 molar. And my final volume, you can actually leave this in milliliters if you want to. You can change it to liters if you want to. Either way. But V1, solving for, I would require 47.5 mils of the 4 molar solution. Second example, how would I prepare 250 mils of 0.2 molar NaCl from 1 molar NaCl? So I have M1V1 equals M2V2. M1 is 1 molar. We're solving for V1. M2 is 0.2. And V2 is 250 mils. So we solve for V1, we get a value 50 milliliters. The question is, how would you prepare this solution? Well, I'm going to prepare it by taking 50 mils of my concentrated, which is 1 molar NaCl, and I'm going to add 200 mils of water. That will give me the total volume that I want of 250. So that's how I prepare. Take 50 mils of the 1 molar NaCl, add 200 mils of water. That would leave me with 250 mils total. Molarity is one of the ways to tell concentration. There are different ways to tell concentration. Percent volume to volume is volume of solute divided by volume of solution times 100. So I got a couple examples here under percent V to V. The first one, we have 10 mils of propanone. It's diluted with water to a total volume of 200. What is the percent volume of propanone? So percent V to V is volume of solute, which is the propanone in this case, so 10 mils, divided by the total volume of the solution, which is 200, multiplied by 100. So it's 10 divided by 200 times 100. And the label on these is percent V dash V. So 5% volume to volume is the concentration of this solution. Second example, a bottle is labeled 3% volume to volume. How many mils of H2O2, which is the solute, are in 400 mils? So we set up the equation like this. 3%, that's what we know, is equal to the mils of H2O2, that's my solute, so that goes on top, divided by the total volume, which is 400, times 100. So to get the mils, I would take 400 times 3 divided by 100, and that would leave me with a volume of solute of 12 milliliters when I rearrange that equation. So 12 mils of H2O2. We can also do concentration in percent mass to mass, just like volume to volume, except we're using masses. In this example, I want to make 2,000 grams of a solution of glucose and water that's 2.8% mass to mass glucose. How much glucose should I use? How much water should I use? So we have the percent, 2.8% mass to mass. We're going to set that equal to X, which is the mass of glucose, divided by the total mass, 2,000 grams times 100. So X, which is the mass of glucose, when I rearrange this equation, leaves me with 56 grams of glucose. How much water should I use? Well, I've got 56 grams of glucose. I know my total solution is 2,000 grams. So the mass of water would simply be the 2,000, which is the total, subtract the 56, which is the solute. So the amount of solvents, which is water, 1,944 grams. So they're the two answers for that problem.